Hey everybody, welcome to the guided problems for chapter 7. Again, I'll just get right into them. A realtor has 20 residential listings under contract. The following table shows the number of days each of these 20 houses has been on the market as of today. Use the data to complete parts A through E below. Okay, so I'll open in Excel so I don't have to type it all in. I'll just bring it over here. All right. So the first thing it wants us to do is calculate the mean for the population. This is a population. It's all 20 of the listings they have. So the mean is going to be the average of all 20 of those. So 35.15. Whoops. Now they want us to calculate the sampling error. So the sampling error is just the mean of the sample minus the population mean. So it says calculate the sampling error for the first 5. So I'm going to do X bar, that's the sample mean for the first 5. That's what I'll call it. So to find that, I'll just do equals average, and then highlight the first 5. 1, 2, 3, 4, 5. And so the sampling error, I'll just call it SE for sampling error, it's just going to be the sample mean, or X bar, minus the population mean. My sampling error is negative 15.35. Next, it wants us to do the sampling error using all 10 homes in the first row, which is the first 10 on this. So I'll say the X bar, first 10, equals average. I'll do the first 10. My sampling error then is going to be my X bar minus my population mean. All right, so how does increasing sample size affect sampling error? So in this example, and generally speaking, increasing the sample size makes the sampling error smaller. And by smaller, we don't necessarily mean like you could argue that -6 is actually a greater number than -15. So by smaller, we mean closer to the mean in either direction. So sampling error is smaller in general. All right, so using a sample size of 5, what is the largest sampling error that can be observed from this population? So remember, sampling error has to do with our distance away from the mean. And so it's either going to be the smallest 5 numbers or the largest 5 numbers that are going to give us the greatest sampling error. So the only way to really do that, figure that out, is I'm going to sort these from smallest to largest. And then I'm going to find the X bar for the 5 smallest. Equals average. Highlight the 5 smallest. So the sampling error for the 5 smallest is going to be the X bar, or the sample mean, minus the population mean. And then I'll find the X bar, or the sample mean, the 5 largest. That would be the average of the highest 5. 1, 2, 3, 4, 5. And our sampling error will be X bar minus the population mean. And so the sampling error, again, this is which is the furthest away from the mean. So it'll be our 5 largest will have a sampling error of 23.25. All right, so there's the first problem. All right, so the next problem says for a population that is left skewed with a mean of 24 and a standard deviation equal to 13, determine the probability of observing a sample mean of 22 or more from a sample size of 32. So that's a whole bunch of information sort of thrown at us. The first thing to recognize is that the whole thing about it being left skewed is just there to confuse you, because as long as our sample size is big enough, and as long as our sample size is greater than 30, then we can assume it's going to follow a normal distribution. So don't worry about the whole left skewed thing as long as your sample size is greater than 30. So let's see what we have. We have a population mean of 24. We have a population standard deviation of 13. We are wondering what the probability of observing a mean, so the mean would be X bar of the sample, would be 22, with a sample size N of 32. So I think that's everything we know. So now we're going to have to figure out a couple of things. And so this is where we would need a formula. So if you have it memorized, terrific. If otherwise, you can use your book, or I like to go to the question help, go to view an example. And it tells us the first thing we're going to need to figure out here is what's called the standard error of the mean. And the formula for the standard error of the mean is right here. Standard error of the mean is the population standard deviation divided by the square root of n. So what I like to do is use the snipping tool that I have here. And actually, I just cut out a little picture of the formula, paste it right into Excel. Then my chances of making an error are way less. We're going to need one other formula to do this, which is the formula to find the z-score for our given sample mean. So again, take my snipping tool, I'll snip this out of there, I'll paste it. Anyway, so I just find that that's easier sometimes than looking it up in the book, as I just look in the help. In an ideal world, what you would do is you would have these written down in your notes and you just refer back to your notes, right? But well, now you have them and you can write them down in your notes. Okay, so to calculate my standard error of the mean, I'm going to take my population standard deviation, divide by the square root of n. There's my standard error of the mean. And now to find the z-score for x bar, whoops, I'm going to say this is x bar minus what's called the mean of the sample means, and we use the population mean for that, divided by the standard error of the mean, which we just calculated. So that gives us the z-score of x bar. And so now what we have to do is convert that into a probability. And so I'm going to say this is the probability of finding less than. This will be our probability of finding greater than. To find probability from a z-score, we can use norm.s.dist. Put in the z-score, true. Remember, this is going to give me the probability of everything to the left or everything less than that z that we have there. So this wants to find the probability of observing a mean of 22 or more. So I'm going to do 1 minus the less than to get the greater than. Wants 4 decimal places, so 0.8079. Oh, that was it. Okay. All right, so on to the next problem. So for a population with a proportion equal to 0.29, calculate the standard error of the proportion for the following sample sizes. So what do I know already? I know a sample size, and I know a proportion. And to calculate the standard error of the proportion, again, if I don't know that, I can go here. I can see, oh, there's the formula for standard error of the proportion. I can snip it out if I want. There's my formula. So now, all I've got to do to calculate standard error of the proportion is use the formula, which is equal to the square root of p times 1 minus p divided by n. And then once rounded to 4 decimal places, 0.0676. Nice work. For 90, all I do is change my n to 90. 0.0478. And then for 135, I'm just going to change my n to 135. 0.0391. There we go. All right, and on to the final problem. So Generation Y has been defined as those individuals who were born between 1981 and 1991. A 2010 survey by a credit counseling foundation found that 54% of young adults in Generation Y pay their monthly bills on time. Suppose we take a random sample of 180 people from Generation Y. So first thing it wants us to do is to calculate the standard error of the proportion. So I'm going to just use the same calculator we'd already set up. And I'm going to say that my n is 180 and my proportion is 0.54. So there it is, 0.0371. See, nice, we already had the calculator in place. Now it says, what's the probability that 115 or fewer will pay their monthly bills on time? So to figure this out, I'm going to put another variable in here, which is x. That's the number we observe, okay? So this will be, for this problem, that will be 115. So then I'm going to do p bar, which is a sample proportion, okay? And our sample proportion is going to be x, what we observe, divided by sample size. And now we're ready to calculate a z-score for a given proportion. Again, we're going to need a formula. I can look it up in the book, or I can go to view an example. And we'll find it right there. Z of p. Z of p sounds like a weird thing to say, huh? I'll snip that out. All right. So we're just going to call this ZP. All right. So the Z of P then is going to equal the square, no, not the square root, P bar minus P divided by the standard error of the proportion. Wow, that doesn't sound right. I'm going to look at that again. Doesn't that seem really high? Oh, that's how we do it though. So P bar minus P. So maybe we just have a really crazy high one. I guess we'll just see. So our probability that it is less than is going to be norm dot s dot dist or z-score comma true See, that's just crazy low. And then our probability that it's greater equals 1 minus probability of less than. So let's see. So this is telling us that if the probability of us getting 115 or fewer out of 180, given that our proportion is 0.54, is what we've observed in the past, and is 0.63 on this one, that the probability that's less than that is in essence 0. So let's see what we did wrong. So our P bar, our X, that sounds right. So let's see if we did this wrong. Oh, you know what I did wrong? I didn't put this numerator in parentheses, right? So what we wanted to do is do that subtraction problem first and then divide. There we go. So now we see that the probability that's less than that's much more, still, it's much different. So 0.9961. All right, that's better. The second one says, what's the probability that 90 or fewer will pay their bills on time? So I'm just going to change X to 90. I'll look at my probability of less than, and it's 0.1408. This one says, what's the probability that 106 or more will pay their bills on time? So I'll change X to 106. This time, though, I'm looking at the probability that's greater than, because it says or more. So that's 0.0941. And then the last one says, what's the probability that between 89 and 107 will pay their monthly bills on time? So what I'll do is I'll put in 107 for X, and I'll take the probability that it's less than 107, and I'm just going to copy that, and I'm going to just paste it right here as a value only. So that's the probability that is less than 107. Then I'll put the probability of, I'll put in 89 for the X. That gives me the probability that it's less than 89. So if I take the probability that it's less than 107, subtract the probability that it's less than 89, that's going to give me the probability of it being between the two, which is 0.8186. And that's it. So hopefully that was pretty doable for you. As always, don't be afraid to reach out if I can help in some way, or even just we can get together on Zoom and walk through the problem. Have a great day and good luck.